Greetings and welcome back. We're going to be covering anti-lock braking systems, how they operate, what they do, what the purpose is of them, and overall the function of the system. Anti-lock braking systems were developed as a safety system to provide safer stopping and maneuverability during a panic stop or a lockup condition. When a tire is rolling across a surface, it has directional stability to it. Once that tire locks up, or the brakes stop the tire from moving, but the motion of the vehicle continues moving forward, that tire is going to stop and slide. When it's sliding, there is no directional stability to it. You may have seen an example of this during snowstorms or ice storms, where somebody's coming down a hill and they lock up their brakes and they turn their wheels, but they're still sliding, and the direction the wheels is pointing doesn't matter. Well, once the tire stops rotating against the contact surface on the ground, it no longer has directional stability. The contact patch with the ground as the tire is rolling is a moment of static friction. The contact patch is always a stationary component of the tire in relation to the road. So the tire is stationary in relation to the road, vehicle keeps moving, wheel keeps rotating, tire rotates and rolls along. But once that static friction is broken and it turns into kinetic friction, you have this static friction of the tire as it moves along, and then if it slides, there's no more stability. It can slide left, right, it can be straight, it doesn't matter. So what does this mean when stopping a vehicle? If a person were to step on the brakes to the point where slippage occurs and a lockup happens, then it either happens in the front or the rear or both. If it happens in the front, take this model for example. If the lockup occurs in the front of a vehicle, moving straight along, and they want to steer and avoid an object. So if they are able to steer and turn the vehicle, the tire needs to be moving in order for that to happen. If they were moving along and the tire's locked, they would just continue going in the direction they were originally traveling. Now that's not as bad in the front as it is in the rear. So anti-lock brakes help the driver avoid an obstacle or a collision during a panic stop situation. So what happens if it happens on the rear wheels? If the rear wheels lock up and the vehicle is going straight, it will stop straight. If the rear tires lock up and the vehicle is making a turn or is on an uneven surface, the moment those brakes lock, those tires are going to continue going in the direction they were going when they broke traction. So what happens is, during a turn, if they lock, they will continue going in that turn and the vehicle can spin around. In worst case scenario, roll over or strike another person or vehicle or any other object. Since the 2012 model year, vehicles have been required to be manufactured with ABS. Before that, it was an option. Some manufacturers did it by standard on their vehicle lines, and other vehicles were available with ABS as an option for a higher price. The ABS does not affect the base brake system. The base brake system still works the same in an ABS vehicle and a non-ABS vehicle. The difference being that the ABS-equipped vehicle has a computer module that is monitoring inputs from the wheels and the wheel speed sensors. Now there's a few ways that can do this, and depending on the type of vehicle will often depend on what type of system it's equipped with. Let's take a look at an example of a wheel speed sensor and how the computer interprets that data. This is an example of an AC generator 2-wire wheel speed sensor. With this handle, I can rotate the wheel hub bearing assembly. And on the back side of the spindle, we have this toothed ring. This one has actually been damaged intentionally right here. One of these has been ground down, so it's not the same square profile. Mounted into the spindle here is an AC generator with a permanent magnet in it. As the toothed ring or tone wheel or tone ring moves past that sensor, there's a very small air gap. And as those teeth interrupt that magnetic field with close proximity to that sensor, that is going to induce an AC voltage or a sine wave or alternating current, positive and negative, into the generator. Then that signal is going to be carried with AC voltage down the wire and the two wires to the control module. The control module is going to receive this signal as an input and determine what is occurring at the wheel. Let's take a look at what the ABS module sees coming from this wheel speed sensor. The picoscope is set up to read between positive 1 volt and negative 1 volt for our AC circuit on the AC generator coming from the wheel speed sensor. Now watch what happens as I rotate this wheel hub assembly and the waveform that is being outputted. It's a sine wave. As each tooth approaches and passes and moves away from the magnetic field, we have an analog signal that shows its relative position to the magnetic field. This is inducing a voltage. In one direction, it is producing positive voltage, and the other way, it is producing a negative voltage. So we have alternating current. You might notice that little hiccup or the squiggle in there. That's our fault. That's where the tone wheel has been ground down on one tooth. And you can see the effects of that. It doesn't maintain a uniform wheel speed sensor signal. Now if I slow down, going very slow, you can see that wavelength increase and the amplitude decreases. As we speed up, the frequency increases. And if I go faster, you can see the amplitude increase. So our voltage output, positive and negative, is going to increase. Go even faster. And back to a stop. So let's walk through a scenario. The ABS control module is monitoring the input from this wheel. Let's call it the left front wheel. If the driver needs to step on the brakes and this wheel stops, the signal goes from a sine wave to a flat line. Or if it's approaching a stop, it's going to be moving very slowly. Now let's talk about how that affects the braking of the vehicle. So what is the control module going to do with this information, and how does it work? Well, control modules operate off of inputs and outputs. They have algorithms built inside of their programming to interpret information coming in, process that information, and then send information out to other components. So inputs are things like wheel speed sensors. The computer cannot control what the wheel speed sensor does. The computer can control other parts of the circuit, but it has to depend on information coming from the wheel speed sensor to determine what it needs to do. So as the wheel is turning and it approaches a slip, so eventually it's going to stop, the signal to the computer shows that that wheel speed sensor is not producing a signal when it is stopped. If it sees other ones producing a signal, then the computer can determine that this brake needs to be released in order for this wheel to keep spinning and maintain directional stability. If it doesn't command this to free up, then it's going to remain locked and the vehicle may approach a dangerous situation. In a vehicle without ABS, if a lockup occurs, if you let your foot off the brake and step on the brake again, you can gain some directional stability back for a moment, but you're still not applying the brakes, or you're applying the brakes less. The ABS control module, once it detects this wheel is no longer spinning, it stops. Then the computer isolates this wheel, and then it reduces pressure to that wheel. Once it reduces pressure, that wheel is allowed to spin again, and then the computer can command it to reapply the brakes, and it will pulse many times a second and allow the vehicle to slow down and maintain directional stability to avoid obstacles or other hazards in the path of the vehicle. So how is it controlling this? Well, it's using brake pressure for one. What it's doing is routing the fluid through a series of valves that are going to open and close, block fluid from going into the brakes. Meanwhile, the driver has their foot on the brakes, so there's an input signal from the driver applying the brakes, and that fluid is going to the wheel that is going to lock up. Normal function of the brakes. Once it detects a slip, it's going to close off the input from the driver, and then it's going to take over control of the hydraulics on the system. This is done through the hydraulic control unit. Here's an example of one of those units. This is the module side of it, and it's receiving all the information into the smaller pins, the lower amperage pins in here, and then it has power supplied to it on the larger pins. So these are a higher amperage driven device. So this also has an accumulator in it, which accumulates pressure from the brake system, and it's going to use that pressure to help reapply the brakes. It's like a reserve chamber to help apply the brakes. On the bottom side of this, we find threaded fittings and sealing seats for the brake lines. This is going to operate these solenoid valves individually for each channel, and it's going to take that brake fluid pressure, block off the driver's input, so it's going to isolate it from the driver. It's going to reduce the pressure, so it's going to route that brake pressure back in through the accumulator, and this is going to pump fluid. Then it takes that stored energy of the fluid that's being recirculated through, and it's being stored in the accumulator, takes that stored energy of pressurized fluid, and then it routes it back to the brakes and lets it reapply the brakes. To allow this in one cycle from a lockup or slip condition to reduce, so it's isolated at a lockup, then it reduces pressure, then it reapplies. Isolate, reduce, reapply. Isolate, reduce, reapply. Isolate, reduce, reapply. And that's the basic concept of how ABS works. Now it's doing this many times a second, and it could be monitoring the rear axle, it could be monitoring each individual front wheel, or it could be monitoring all four wheels individually. Depending on the type of system, how many channels it's configured with is going to determine what the overall outcome is going to be with the system in operation. All right, let's talk about how this is configured on certain vehicles. We'll start with the most basic form of anti-lock braking systems. The one-channel ABS. This one channel is referring to the input to the ABS controller. So this vehicle only has one input for both rear wheels, and no other wheels are being monitored. Why would it be just for the rear wheels together? Let's think back to height sensing proportioning valves and what kind of vehicles those are found on. Those are on vehicles where chassis can be loaded heavy or empty, like in a cargo van or a pickup truck, and the back end is usually pretty light when it's empty. Well, those chassis are also prone to rollover in the event of losing traction to the rear wheels. And a lot of the times they're rear wheel drive. So these vehicles are usually the type that will have a single channel ABS. And this one channel is monitoring wheel speed to both rear wheels. Where would they measure both rear wheels from? Because one can spin faster than the other. How does it know? Inside the differential, where the driveline comes in from the transmission, comes into the rear axle and it splits 90 degrees and goes to each wheel. We have the carrier. This is in the differential, so in the pumpkin-shaped part of the rear axle. Now notice what it has around the outside of it. This is a tone wheel. So this would use a wheel speed sensor that is mounted in the rear differential, most likely, monitoring speed to both rear wheels. If either of those wheels locks up, it sends a signal and the computer can adjust and perform its isolate, reduce, reapply sequence to the rear axle, to the rear brakes together. And that will prevent the rear end of the vehicle from sliding sideways and potentially catching and rolling the vehicle, or going out of control and hitting something sideways. Next is 3-channel. 3-channel maintains the same configuration on the rear, where we just have a single channel going to both rear wheels, with the addition of individual circuits going to the front. So we have a left front channel, a right front channel, and a rear channel. So this allows the system to control each individual front and the back two together. 4-channel is just as the name suggests. Each individual wheel has its own wheel speed sensor, and it's being monitored by the ABS unit, and they are being monitored by the ABS controller. So each one of these is an input, and there is circuitry built into the valve assembly which allows the system to isolate, reduce, reapply each individual wheel as needed. So if only one wheel is locking up, the system can control the brake pressure to that one wheel alone. The components that are necessary for ABS operation on a vehicle are going to be a vehicle speed sensor or wheel speed sensors, an electronic control unit, a hydraulic modulator assembly or a valve body controlled by the control module, and finally the ABS warning lamp. This is an indicator bulb that lights up on the driver's instrument panel and notifies the driver, first of all, that the system is present, and if that light remains illuminated, the system may have a fault. These systems can be what are referred to as non-integral and integral systems. The integration of many of these components into one component assembly is an integrated unit. The ones that are not integrated may have, maybe the hydraulic valve assembly is separate from the module. They could be together or separate, also being separate from the master cylinder area, while other assemblies can be integrated. This is a totally integrated module where it has the electronic control module component right here. It has the fluid reservoir. Notice there's no booster on this. This controls boost pressure itself electronically and provides ABS function through the valve body and out to each individual brakes. This would be serviced as one unit rather than each individual component. The advantage for a manufacturer to design a vehicle with an integrated unit is that it costs less to manufacture, for one. Two, it takes up less space on the vehicle and there are fewer wires going to different areas. And if it needs to be replaced, it's one whole unit that gets replaced. Now, what does that mean for the customer? If there's a problem with that unit's going to be a lot more expensive. It's going to have a higher cost for the repair of the system compared to a vehicle that has individual components located at different parts of the vehicle. You're more likely to come across an integrated unit or an integrated system at this point in time. Earlier years of anti-lock braking systems could be either, and the first ones that came out were more of a piggyback option onto the standard braking system, where the components were individually located at different parts of the vehicle. During an activated ABS stop event, or a lockup condition while the driver is stepping on the brake pedal, the driver is going to feel that system engage. And what the driver is going to feel is that brake pedal is going to get stiff. because it's no longer able to apply the brakes directly. Since the system takes over and routes the pressure around and back into the system where the driver's foot is applying pressure, that pressure being relieved from the brakes, going into the accumulator and pumping back through the circuit, is going to enter the other side of the hydraulic system where the driver is applying force. So the pedal is going to have a bump to it. And when this is happening several times a second, it's almost going to pulsate or vibrate. The driver should be aware of what is going on, but a number of times people do not understand how the systems work, which is understandable. They're not professionals in the industry. They're just professional owners of their vehicle that they're driving. So some systems may try to mask it a little bit more than others. Higher end luxury cars would have that feature built into them. For one, it would take more to produce a system that has extra engineering and development into it to mask the condition of what's occurring hydraulically and mechanically to the driver, so they don't get this feedback and panic and say, oh, what's going on? Something's wrong. When the vehicle is just taking over for them and they are able to focus on driving the vehicle and maneuvering as they need to. Let's go take a look at one particular system on the 2014 Honda CR-V. Pay attention to a warning light right here. It's a yellow ABS system warning light. It illuminates for the bulb check and then times out when the system determines there are no faults in the system and it can turn off. ABS off. That light is being controlled by the control module itself for the ABS system. So if the driver turned on the vehicle and that light remained illuminated, what does that mean? Well, it means that the system recognizes that there's a fault. And if there's a fault present, there's usually a trouble code associated with that fault, and the module would need to be scanned in order to find out what the fault is related to. And that gives the technician a ballpark as to what needs to be tested to figure out what needs to be fixed. It's concern, cause, correction. Follows the same pattern. So maybe you recognize this setup. This is the one with the master cylinder reservoir that's hard to reach, and an even harder to reach master cylinder. Well, those lines, if you recall, see them running around the firewall there, come around to the hydraulic control unit. This is not an integrated system. This hydraulic unit and the module are separate from the master cylinder assembly. So it's not completely integrated, but these two components are usually coupled together. There are brake lines going to each individual wheel. So we have the two lines coming in from the master cylinder, one for front, one for rear. And then within those, we have two for the rear and two for the front. I'm not sure if that's rear and that's front. I'm just guessing. But we have four individual lines going to each individual wheel. So this system is a 4-channel system just by looking at the control module and hydraulic control unit assembly. Now we're just scratching the surface when it comes to anti-lock braking systems. On many newer vehicles, these same systems integrate with other systems to control vehicle stability and possibly traction control. So applying the brakes individually has its advantages other than just avoiding a collision. But we'll get into that more later, and I hope you gained something from this video. Until the next one, thank you.